When a disaster strikes, a flood, a conflict, a famine, the world wants to help. But imagine the chaos on the ground. It's overwhelming. Where are the people who need help the most? How can you possibly reach them? And how do you keep your own people safe while doing it? These are the questions that keep aid workers up at night. Today, we're going to look at how a whole new perspective is starting to change the answers.
You see, for any humanitarian organization, every single mission is a huge logistical puzzle. Information, it's often scarce, it's outdated, or it's just plain wrong. Roads might be gone, communication lines totally cut, and entire areas can be way too dangerous to even think about entering. It's a constant, brutal fight against the unknown. But what if you could get a clear bird's-eye view of everything, bypassing all that chaos on the ground? Well, today we're going to explore how that eye in the sky is becoming a total game changer for humanitarian aid, for better and, as we'll see, maybe for worse.
We are living in what people are calling the new space age. And no, this isn't about landing on the moon or sending rovers to Mars. It's about something much, much smaller. But honestly, it's arguably just as revolutionary. This whole revolution is happening on a tiny scale. I mean, we're talking about satellites that can be as small as 10 by 10 centimeters. Think about that. These things, called smallsats and CubeSats, are thousands, sometimes millions of dollars cheaper to build and launch than the old-school satellites. And that has completely thrown the doors to space wide open for a whole new crowd. Universities, startups, even nonprofits. And it's what people are calling the democratization of space.
Okay, so with all these new eyes up in the sky, what can we actually do with them? Well, the potential for humanitarian work is just massive, and it's all powered by a few key pieces of technology. It really boils down to three main satellite superpowers. First, you've got Earth observation, or EO, which is basically a fancy way of saying taking pictures and collecting data about the planet's health. Second, GNSS, which you definitely know as GPS. It tells you exactly where you are. And third, SATCOMs, which give us internet and phone service in places where networks on the ground just can't reach. So let's see how this actually works in the real world. Let's take Nigeria, for example, where ongoing conflict made it totally impossible for aid workers to get in and do field surveys to figure out the scale of a huge food crisis. It was a massive data black hole. I mean, how are you supposed to help people when you can't even tell how bad the problem really is? This is where Earth observation comes in clutch. The World Food Program used this incredible technique called NDVI. Now, essentially, satellites can measure the greenness of the landscape from space. Healthy growing crops look totally different than ones that are struggling. So by analyzing these images over time, they could accurately figure out crop yields and food security across the entire region, all without a single person having to go into a dangerous area. It's a brilliant example of remote sensing's power. But, it's not just about collecting data from above. It's also about creating connections on the ground. Take the rural village of Mapapa in Zambia, where access to the outside world was extremely limited. Then, the YouTuber Mr. Beast's Philanthropy arm came in and, using Elon Musk's Starlink satellite internet, connected the entire community to high-speed internet for the very first time. I mean, talk about opening up a world of education and opportunity. So when you put it all together, the benefits seem crystal clear. Satellites can help us predict crises like droughts, they can keep aid workers safe, speed up decision-making, and even provide real transparency on how aid is delivered. It sounds like a perfect solution, doesn't it? Well, the story doesn't quite end there, because for every problem this technology solves, it seems to risk creating a new one. That view from above, it isn't always as clear or as fair as it might look. The real problem can be summed up with this term, the difference multiplier. And the idea is pretty simple. Satellite technology isn't some neutral tool that helps everyone equally. Instead, it often takes the gaps that already exist in wealth, in power, and access, and just makes them even wider. So how exactly does this happen? Let's break down the divides that this technology can create, starting with the organizations themselves. Just take a look at this comparison. On one side, you've got a large international NGO. They've got the budget for private satellite data. They've got in-house experts to analyze it all, and they've got dedicated training programs. Then, on the other side, you've got the small, local NGO, the ones who are often the first people on the ground. They have none of that. They're stuck relying on whatever limited free data they can find and are often left out of training. This just risks making them even more dependent on their bigger international counterparts. And then there's the divide between crises. The CNN effect is a real thing. High-profile crises get all the media attention, and with it, the resources. When the war in Ukraine started, tech companies rushed to help, with SpaceX providing its Starlink internet service for free. It was a crucial lifeline, no doubt about it.
But that same technology isn't being rolled out everywhere. And even when it is, the impact can be, well, complicated. In a completely different part of the world, reports are suggesting that Starlink is actually creating new social divisions within a remote Amazon tribe. It just goes to show you how access and attention are so unequally distributed, and how even the best intentions can have consequences no one saw coming.
And the divides don't stop there. They go even deeper. Inside the aid agencies, the tech specialists start to gain more power, while managing things remotely can mean that the real on-the-ground risk gets pushed onto the local staff. And among the people who actually need help, not everyone benefits equally. An elderly person might not be able to use a satellite phone, and a satellite image can't detect psychological trauma. The technology only sees what it's designed to see, and it can miss a whole lot of human need. So, where does all this leave us? We've got this technology that has the power to save lives on a scale we've never seen before. But it also risks digging the very same trenches of inequality we're trying to fill. Ultimately, this isn't really about the technology itself. Satellites are just tools. They're incredibly powerful tools, yes, but they aren't inherently good or bad. Their real impact, whether they close gaps or just make them wider, depends completely on the choices that we make. Who gets access to them, who gets the training, and whose needs are we prioritizing? And that really leads us to the final, critical question. The technology is only going to keep getting more powerful, more precise, and more widespread. The real challenge for us is to make sure our humanity keeps pace. As our tools get smarter and smarter, how do we make sure our compassion does too?